First talk in the morning after a party. I hope you're gonna bear with me in this. I'm gonna talk about attacking modern web technologies. And when I wrote this title, I was trolling a bit. The reason for that is that modern is like a weird word, right? Modern means probably that it's old, and it's so old that people are actually using it. So I will actually try to not talk about like the common ways of attacking something like SQL injection or XSS. I will try to think about the web application that has thought about a bunch of things. Such things as sanitizing your input, maybe moving over your file upload to a different domain, and probably to a third-party service, like a cloud bucket or similar. So my name is Frans Rosén, to begin with. When I write the Swedish Ninja, it sounds super cocky. And the reason I did this was I had this profile picture from way back. And I met some friends outside of Sweden. If you know Sweden, it's like, this is up north. This is in Sorsele. It's like 35°C. And I showed a couple of friends outside of Sweden. And they were like, yeah, you're hacking. You're dressed as a ninja. And I was like, no, this is how you survive in Sweden. I work as a security advisor on Detectify, and Detectify is like, we're trying to automate a bunch of security issues. So we're monitoring your site, we're testing for a bunch of stuff. And working as a security advisor, that means that I need to advise around security. So I need to know about security. So I need to force myself to extend my knowledge beyond what's already out there. So I'm really trying to do that. And one of the ways I'm doing it is by researching bugs and using bug bounty for that. There's been some talks earlier on this event about bug bounties, at least like mentioning it. Bug bounties, in short words, is basically a company puts up bounties, basically money or rewards, and they say, please hack us. And you go to them and you look for stuff. You basically get a get out of jail free card, but you don't go to jail at all. So. And you get money, so it's like, yeah, it's the reverse of get out of jail free card. I do a blog on labs.detectify.com also around like new ways of thinking in terms of security issues and stuff. I also do a bunch of live hacking events. So a bunch of these companies like HackerOne, which is a marketplace, they put up like a live hacking event. So we get invited to a city, and a company goes there, and they say, please hack this company. And there was a big event in Vegas last year, and I won. So I won the MVH. So I have like a boxing belt at home, which is awesome. We also competed as Team Sweden in San Francisco earlier this year, and we crushed Team Belgium so hard. Like we were number 1, they were number 2, but we were like twice as good, which was awesome. So I started actually as a developer. And this is the logo of PHP, and I started as a PHP developer in 2004. It should probably look more like this. Like it's an evil elephant. It's an awesome elephant. I love this elephant. But it's like, if you don't know it too well, it might stab you in the back, right? And I started as a developer, and I was working as a consultant. And I met a couple of friends, and they were doing a lot of security things. Back then, doing security things means you were smiling behind your computer in the office, and suddenly that guy knows all the passwords in the office. That was how he did security. But there was something happening. So this is probably 4 or 5 years ago that PayPal sent at least me an email saying, if you find security issues on PayPal and tell us about these issues, we will pay you money. And we don't need you to sign a contract or anything. We just want you to tell us about the bug. Please hack us, basically, and tell us about what you found, and we're going to pay you money. And when I saw this, and my friends was doing this, I tried to ask them, like, what are they, like, what do they want? What should I look for? And they showed me some tricks. And so I started looking into it, and like, this is super interesting. And being a developer from the start, I realized that I knew a lot of these things, just I knew the reverse of it. Like, never trust user input. That was like one of the things I thought about, but I didn't really know how bad it could actually get. So I took a look at PayPal. I registered my account. I made like a business account and a personal account. and I sent some money between my both accounts. And I was able to, I actually found a way to trigger a cross-site scripting on PayPal. So I could send you money, and you would read it, and it would trigger. Which was the perfect place of having a XSS, because you could basically trigger them to send back more money. And I sent it to them back then, and I told them, this is the print screen, this is what I did, this is where I put it in, I used this kind of way to send the money. And they came back a couple of months later and hey, what's your PayPal account? We want to give you $750. And I'm like, what? PayPal asking me for my PayPal account to give me money. Haha, that's fake, and then remove it. But that was actually true. They wanted to pay me money because they identified it being a risk. So when this happened, and I realized this was not a fake email, there were a bunch of companies doing the same thing. So I totally freaked out. I was like, okay, I'm going to help all of them. I'm going to try to find something at least on all these companies. I've never had that many T-shirts in my life as back then, because that was basically what they were sending out. So all these T-shirts, probably most of them did not even pay money. They just sent you these T-shirts. And this evolved into being something they call a human-powered marketplace. So there are a bunch of these companies, HackerOne and BugCrowd, trying to get us bug bounty hunters into their marketplace so we can help their customers, and their customers can send money over to us. So this is the evolution of this thing where you can actually have a middleman in between. So the cool thing is we working with automation, we realized we can do the same thing, right? So we just, okay, so all these researchers, as soon as you find issues that we can automate, stuff that is not custom to a specific company, but some general misconfigurations or easy to spot bugs, or some complex flows, but it's a plugin that everybody uses, or similar. They can give them to us, and we're going to pay them every time we find the bug. So it's almost like a royalty thing, which is quite cool. So the rundown for today is how did I get here? We're done with that. That's awesome. I love a rundown where we can tick off stuff. I'm going to start off small because you had a rough night yesterday, and with an example of in real life case scenario. Then I'm going to move over to an old technology, but I will approach it in a modern way, in terms of we can actually use this legacy things to abuse a properly set up infrastructure. And upload policies, the worst thing ever. I know a lot of companies are starting to use them. They have a lot of benefits, super easy to do wrong. I will try to explain a bunch of stuff with that. Also, postMessage, classic thing, which is it has been there for a long time. Everybody's using it for all different reasons nowadays. And I will explain a bit how Slack did it and how they did wrong. So, Werkzeug Debugger. I was going to an event in Coventry, in the UK. And they invited me for a Python conference called PyCon. And before the Python conference, I was I know Python, but I don't know exactly what I should approach. And I want to talk with them on their language, right? So I approached it in the terms that I want to look for a framework that a lot of people uses. And I want to see if there's anything quite obvious that shouldn't be done. And trying to approach it in a very sane way, being outside of the Python community. So I found a framework called Flask. Flask was an easy to set up web framework for Python. And when I started reading the documentation, I was starting reading, okay, what do Flask have? And one of the things it has was Werkzeug Debugger. And when I started reading the documentation, it said, must never be used on production machines. When you read this, you think, that's a lot of people has done that. And the thing is, this wording is pretty wrong. There was a big reason why this should not be run. But on production, this must never be freaking online, ever. Because the Werkzeug Debugger had a very different component. It added a route to your framework called console. And when you went to /console, the UI was pretty basic. It had an input box, And when you wrote something in the input box, that code was evaluated in Python. So you could basically go to this /console and just write code that the server would execute on the server as the user that runs Python. This is called like a remote code execution. They have a scoring system of vulnerabilities. This is 10.0 out of 10.0. And this is per design. So this is very, very convenient if you're running it locally, but it's very, very not convenient if you're running it online. And so the wording here is a bit bad, I would say, because when I saw this, I was like, okay, let's look for it online. And the interesting thing is, if you had Werkzeug Debugger on, it would show up in the header as Werkzeug. And when I see show up in the server, I mean, whenever you requested a website from this site, it would respond with response headers saying, hello, Werkzeug is all here if you want something. So I did what everybody else would do. I went to a search engine that looks for metadata called Shodan. And I literally went in and Werkzeug. And I was presented with a bunch of companies. This was so bad. I was like, this is not really what I was expecting before this Python conference. But one of the companies that I actually saw was this. So first I see there's a huge SQL error. That's bad in itself. It's probably not an injection or anything. It's just that when this scanner of the Shodan was visiting this website, it had this specific error. But this also exposed that the Werkzeug was enabled. And the SSL certificate was very convenient here, because when you look at it, you see there's a company called Patreon. And I knew Patreon from before. Patreon was basically, or it still is, a website for YouTubers to get crowdsourced funding. So if you're a YouTuber having 10,000 subscribers and they pay you $1 a month, you get $10,000 a month. And when I saw this, I knew that Patreon had a responsible disclosure policy, meaning I could contact them and tell them about this issue. But when I went to this website didn't respond to me. It was offline, which was a good thing. But just to make sure, I took the IP address that it was pointing to, and then I put a loop trying to ping that IP address. So as soon as it would open on port 443 or 80, it would tell me and send me a Zapier push. And I waited for a couple of days, and suddenly in the morning, I look at my phone and I have a Zapier push saying this Patreon site is online again. And I went to the website and I see the exact same error. And I go to /console and popen who am I? And it says root. And I was like, this is pretty bad. So they had a responsible disclosure. I wrote them. I actually wrote in the header, urgent. Remote code execution due to Werkzeug Debugger being enabled on an online interface. You go to /console, just insert your PHP code and you run as root. That was everything I could do, right? I could potentially go inside it as root, shut it down, but I didn't. I let them know everything, and then my case closed. I think it was 5 days later, they sent me a response back. Oh, yeah, we know, it's pretty bad. We've been thinking about moving it, the dev environments. I'm like, what? This is not how you respond to a remote code execution without authorization. I just went to a website, wrote a Python command. You should not react like this, and not after 5 days. So I saw this, and I'm like, okay, hopefully they did. A couple of days later, I see on Hacker News that the crowdfunding site Patreon has been hacked. And when I saw this, I'm like, that's probably the reason. If they reacted like that for this specific thing, that is probably the big reason why this happened. And when you read the security announcement, it said, due to the bug environment being online. And I'm like, this is the reason. So I sent them an email like, hey, can you confirm that this is the case? Because you need to understand, if this is the case, someone else knows about this thing. Of course, it was in the documentation, right? But knows about this thing, hacks a bunch of websites, extracts their data, and puts it online. And nobody responded. And I looked at Twitter, they are like in the war room, sitting there like, what the hell, we need to like fix the media, we've been hacked. So we took the decision internally at Detectify, this must be the reason, like this is obvious. They had a remote code execution, they got hacked, it must be a correlation. So we put up a blog post without actually having the confirmation of it. Just the tiny little signs that this was actually the thing. And we put out how Patreon got hacked and explained what the Werkzeug Debugger was and how it is. They came after that and confirmed that this was actually the case. And said that if we could be like the scapegoat of this, it's fine. Like hopefully other companies would be getting this fixed. Also, Werkzeug fixed this, so now you need like a PIN code to get to this console. Another company that reacted in a different way, that was Uber. I reported this on a Saturday to them. They actually, he was at the gym and like he ran home. That's basically how you react. They also like paid me like $5,000, which was like pretty nice for just this tiny research for this event. And AppCache is something that, moving over to that, AppCache is something that has been on the in the web browser for a really long time. But, and I can explain what it is. Basically, it's not modern at all, but me and my friend Matthias was trying to use AppCache to attack modern websites. So AppCache is basically application cache. That means that you can go to a website, that website can say, please cache these things, and as soon as it does, it will take all the URLs you ask it to cache and save them locally. And that means that as soon as you unplug your Wi-Fi, or you don't really unplug your Wi-Fi like this, I don't know how you unplug your Wi-Fi, there's no sign for it. But as soon as you do that, it can actually use your fallback. So it can use the files that it was actually downloading. So if you would install one of these manifests on your website, you would put it in a manifest attribute on your HTML node. That one will download the app cache, install it in your web browser, and it will go through the cache manifest that looks a bit like this. And this manifest contains a bunch of URLs that your browser will request, and then you're actually able to also provide a fallback. The fallback is what I mentioned. So as soon as you get like a 404 or like a 500 or an error message, it will try to use the fallback instead. And the thing was, this is pretty interesting because me and Matthias was looking at this the last year. And there was also another guy called File Descriptor, which is also like, he looks for bugs in browsers. And both of us was looking at this in the same way. And I'm pretty sure, so I'm not going to take away the credits from him as well here. But the thing we looked at and we realized was that any website on your domain can use this manifest. And if you point it to a manifest, and say fallback, you can define what paths in the fallback that should be used. In this case, there's a dot there, but the dot could actually be like a front slash, and that would mean everything on this whole domain. And if you combine this, and I will try to explain exactly what happens here, but remember that the fallback is used when the content or resource is inaccessible. So the first approach here to how do we make content inaccessible? The whole attack method here is that if we can run this, have this HTML manifest on a website, we can install an app cache there. The app cache would make sure that every inaccessible file has a fallback, and the fallback is to us, meaning if we can make all the files, the file URLs, inaccessible for the user, we can make them trigger the fallback, which we control by installing the manifest to their browser, and give the data to us. So we get the URL that they actually wanna request. Sounds crazy, right? But it actually works. The first attack is like, how do we make every content on a domain inaccessible? And the thing is, there's something called like a cookie stuffing or a cookie bomb. And the whole idea with it is that you, on the client side, with a JavaScript, sets a very, 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 very long cookie, or a lot of cookies. So this is like 10,000 of 1,000 characters long cookies. And when you do this, most of the time, if you request the same domain after this, it will say 500. Your request header is too large. So that's the first idea. We can actually, if we have a XSS on a domain, we can actually do a cookie stuffing and make them not be able to access the website. And the thing is, okay, you need an XSS, but then game over, right? No, but we're not attacking their main website here. We're attacking their sandbox domain, their usercontent.com domain, their Amazon AWS domain. We're attacking their sandbox. We're attacking something that is just outside of the things that they care about, but that contains all the content everybody else cares about. So the bug that we found that was existing in every browser was basically that if you would have an HTML file under a path of a, let's say, usercontentdomain.com, which is like not really the same thing as the main domain, but as soon as you download something from the main domain, you download data from the sandbox domain. It's a very common and good way of like, we don't want to host content on our like acme.com. So we have acmeusercontent.com to isolate the user content from the live site. But basically, if I could run XSS on that, and nobody cares about XSS on a sandbox domain, on a user content domain, that's like expected almost. If I could run an HTML website there, I could install a manifest. That manifest would point to a fallback file, and that fallback file will take the URL it's on and ping my host with it. And I will say that it would apply to all the protocols, and I will also install the cookie bombing. And the thing was, when I read the specification, I was like, because this was not expected to do, and I will show you how it actually looks like on a real website. So they said, like, manifest can only specify fallbacks that are in the same path as the manifest itself. And that was a very stupid description, because what we could do was basically to say, the manifest is here, but I want a fallback of the whole domain. So even though I have a user path, like user 1234, I could say, but the fallback for the whole domain should be this specific file. And that is allowed during this specification, because this one says the manifest should be next to the one installing the manifest, which it is. So this was confusing. It could mean the path to the fallback, and that was what every browser thought. And now you're like, what the hell is he talking about? What is this? How does this work? So I will try to show you. This is actually a live demo from Dropbox. And this was patched early last year. And I will try to show you. So the problem is I can't really do it on the website today because it's not there anymore. So I will tell you briefly what's happened here. Dropbox had something that is called Dropbox User Content. And you could basically host like stupid websites there. But they realized like, okay, having XSS on Dropbox User Content is pretty bad. So we'll try to prevent that. So whenever you went to a HTML website, it will download. But they forgot that XML can be turned into HTML. So I found that you can still like put a website on Dropbox User Content with an XML file. XML files could install the AppCache. So what happened was I made this public URL. When you go to it, it will install the AppCache manifest. The manifest will also run JavaScript, installing the cookie bomb, so everything on Dropbox User Content will be unavailable for the user. And as soon as you go to the real Dropbox and press download, what happens? You get redirected to Dropbox User Content, which is the one I installed the AppCache on. And I get all the URLs you're trying to download from Dropbox. So that's, I will try to show you in the flow what's going on here. So this I'm showing the installation of manifest. You can see the manifest there. And you go to it, and it actually installs the manifest, and it says in the console. The thing is, now, if I go to a URL anywhere, I will just alert them and say, I took your URL. So going to the real Dropbox, anywhere like 2 days later and pressing download, my script is triggered. So this is not using like, this is not a stored XSS or anything. It's just I'm installing this old legacy idea. And this is my website showing that I logged the file that I could download. And since these were like one-time usage only URLs, but due to the fallback, the victim never used the link. So I could just take the link and download it myself. So the whole bug that I sent to Dropbox was basically I could run XML on download Dropbox user content as HTML. That's a bad thing. I could install a manifest with an XML, which is like, of course, it's exactly like HTML, so it's weird. But I can install the manifest from a path to the root of the website. And any file downloaded from Dropbox would use the fallback XML HTML page due to the cookie bombing, which would log the current URL to my external logging website. And every secret link would be leaked to the attacker. They paid $12,000. Like, that was the cool thing with this. It had no expiration. AppCache is a legacy, it's like service workers' little brother or like old father. I don't know, but it's like the legacy version of service workers. And AppCache did never expire. Unless you told it to. So you could basically have this silently running there for forever until they like wiped their whole cache or website cache. The cool thing also was that a bunch of browsers did stuff. So they said like, okay, Dropbox user content should not have any more XML, HTML websites. We're gonna remove the whole functionality of public directories on Dropbox, which was pretty interesting. They coordinated together with me and Matthias to every browser to make sure that all the browsers were mitigated. They mitigated one thing, and that was that fallback cannot be installed on the root of a domain from a path. And if you see that, you can basically think like this. Okay, this means that this bug is still there. It's just that it's been mitigated to not break out of a path in the URL. And they're all trying to deprecate AppCache. It's probably going to take a bunch of more years to do that. And Dropbox actually fixed so they have like random subdomains for user files, which prevents the whole thing. So all the browsers fixed that. They paid a bunch of like browsers actually pay bounties as well, which is quite cool. This was just a research coming up out of nowhere. So that was pretty cool. But AppCache vulns are still possible. And the requirements to attack someone with this is that you need HTTPS, which is like obvious, of course. Why not? But that's not a problem. And files uploaded needs to be able to run HTML, meaning this could be a sandbox domain or anywhere, and if you can run HTML on it, you can install a manifest. And the files could be on an isolated sandbox domain, meaning you can, someone maybe says, we don't care about an XSS on this domain because this domain is actually our sandbox domain. We don't care about it. But if people are downloading stuff from the production website, from the sandbox domain, and you can steal that content, I think they're gonna care. Absolutely. And the interesting is the attack you now need to do is that you need to be in the same directory as other users. So if you have like a bucket upload thing and you upload user content to the same path in that bucket. So multiple users' content are in the same directory. You're doing it wrong, and this is one of the reasons why. Service workers are AppCache bigger brother. Okay, so the little brother was AppCache, whatever. This relation hierarchy is like hard for me. So, but the service workers are similar in terms of how to exploit them, but they have the restriction that you can never install a service worker if the service worker is in a path. So service workers needs to be installed from the root of a domain. So that means that if you have you're using an S3 bucket, for example, to host your content, and you're sandboxing it, but everybody can upload files to the root of the bucket. So the bucket there's no paths in the bucket, it's just user content inside there. Someone can, if they can upload like arbitrary files, they can install a service worker, which is like just as bad. You can make like secret requests as the user if it accesses any of the files. You can also do like a fallback thing, and you can steal the URL. So it's just as bad as AppCache, but it has a restriction that you need to put content on the root of the domain. And going into this, talking about like bucket uploads and stuff, I want to move into the upload policies. This is a really, really interesting technology. The reason why it's interesting is that when you started with web and building a web page back in the days and you needed a file upload, you basically thought like, okay, I will upload a file and I will keep it in a directory outside of my application. And hopefully that works, like cross my fingers. And then a bunch of cloud services starting to offer you ways to upload files to them. And they had an infinite storage. Like it was like, just put files here, no problem, we'll solve it. And you're like, this is awesome. I don't need to change disk or increase my disk space anymore. So you move to it. But the way you moved it to not like change your application too much was that you got the file and then you connected to S3 and moved it over to them. That meaning that instead of taking 10 seconds to get the file, it's taking 20 seconds because you need to send the file away as well from your site to S3. And this content providers or like Amazon S3 and Google Cloud, they realize like this is probably a bad thing. What if we sign a policy or the user that has the website signs a policy and gives the policy with a signature to the user, and if the user uploads directly to us, can't we validate the policy then and just allow the upload to be made directly to us? That means that you can just upload directly to the cloud service. And they're like, oh, this is an awesome idea. That should work. The problem is, so it's actually secure and faster. That's awesome. But it's super easy to do wrong. There's so many ways to actually not do this in a good way. So first of the ways is like, this is how it looks like to begin with. Basically, you do a post request to an Amazon AWS bucket. Inside the request, you have a policy. And you have AWS access key ID, which is like the one that was signing the policy. And right in the bottom, you can't see it. It's like here. You have a signature. And the signature is basically used to make sure that the whole request is intact. So the only thing that is differing is the content, because you can sign the policy with the content. So the policy tries to explain where the file should be uploaded and how the properties of the file is. So that means that this policy basically says you're allowed, until the 4th of March this year, you're allowed to upload 2 example uploads with a file name that starts with this prefix. The file will be able to be read by anybody. When you're done, it should redirect to this domain, to this URL. The content type needs to start with nothing. And the content length range of the file that you upload needs to be between 0 and 524288. If your content, together with this policy, is correct, the file will be uploaded. That's how easy it is. The problem is, on basically every line in this policy, you can make mistakes that is like not great at all. The first thing that is the thing we mentioned before is like when you have a key in the policy and you said it needs to start with something and you don't have a path separator, we can place stuff in the root folder. And remember what I just mentioned about service workers and AppCache. And this depends, of course, on the other mistakes in this one, but this is a first step of actually getting to kind of claim a bunch of stuff in this bucket. So path separated is one thing that needs to be there. Another thing is like if you have a starts with key and doesn't contain anything, we can replace anything in the bucket. It's quite like when you see it, you're like, of course. Why wouldn't you? That's the same thing. If you have the same prefix of all the files, of course, one person can override another one's file. Because S3 doesn't care about the file already being there. It will just like, okay, this is the new file, and replace it. Another thing is content type uses empty starts with and content disposition. And this is what I'm mentioning. Like, so if we have starts with content type and it's empty, you can put, of course, whatever content type you want. And now we can have an HTML website. We can have run JavaScript on it or whatever. But the thing is that people don't understand is that even though you have content type uses starts with, and you force it to be an image JPEG, you can actually fool a bunch of browsers that if you give them an invalid image type, but then use a semicolon and give them a proper MIME, they will use the proper MIME instead. So this one, if you have this content type on a file today in a browser, you will get it back to you as text HTML. Meaning that the starts with on the content type doesn't mean anything. It's like whatever you want. So even though you're specifying the policy that this kind of makes sense, the MIME type needs to be 100% strict, because you can fool the browser to make stupid assumptions that this should not be an image. It should be HTML instead. Another way to do this without having the policies in there is called Amazon or AWS STS. And it's like secret token service or similar. It's no service token service, I think. It's a weird name. But the thing is with this is you can generate temporary credentials, client side, which is quite cool. It's based on IAM. So you write the IAM role, and where you basically write the IAM role, sign it with another with the access key, and then there's like a AWS STS that you can request to get service tokens, which is following. So it's basically the exact same thing as with S3 policies, but the only difference is that you can't see the policy that it's using as the user. So client side, you can't see that. And kind of makes sense, because that would okay, EC2 is accessible, now I can access whatever. So it tries to use security by obscurity. And the whole way to not do it is do never ever use wildcards if you're doing one of these roles and using this client-side way of generating them. Never do S3 or EC2 or similar. Be 100% specific and realize that the user can generate how much credentials they want for this specific thing. The whole way it works is that, as I said, you point it to a web identity. Or no, you create a web identity, sorry. And then you basically have a web identity token that you're generating. And this is to try to hide the policy. But in the end, you can sign something that specifies what role you should use. And by fiddling around with that dance, you end up with having this one in the response. Basically, access key, secret access key, and the session token. So using these, we can actually use them in AWS CLI. We can just use these tokens we got back, and then we can just play around and see what we got. So we can we have access to S3, everything. And in this case, they had S3 star and EC2 star. And we actually found this on this live hacking event in San Francisco for a big company. And they were like, okay, this is you have everything, so we're going to pay you some money for it. Another way to another vulnerable flow is that in this case, it was Google Cloud. So there's no difference between these two services. In this case, basically, you posted to their own website and said, oh, can you please give me a signed URL, please? And you give it a file name and a content type, and it will give you back storageapis.com storage, a storage Google APIs, and it will give you a signed URL. The cool thing was you could just select whatever file name you wanted, and you could override any file that someone else had. And you can just ask for any file that you want, and you would give it. Or they would give it to you. So you could basically traverse, and that was what I did. I could traverse invoices and stuff, and I showed them I can probably access all your invoices. So they were like, okay, that's everything we got. We're the invoicing service. So this is not great at all. So the whole idea with this is your own policy logic. This is the worst thing. This is don't learn anything from these slides I'm going to show you now. Don't learn, of course, but reverse. Don't do this. Please don't do this at home. Goal is to reach the bucket root. That's the idea. The thing is with these services is that if you can ask them, the website, please give me a signed URL, and they would give you a signed URL of the root of their bucket, the first directory in their bucket, you will get the file listing. Meaning you could basically see everything that is in the bucket, and then when you see that, even though they're not accessible by anybody, you can ask for a signed URL for that file. So it's like a more complicated way of doing a file listing structure on a website. Like they forgot to remove the file listing on your upload folder. This is exactly the same vulnerability, just that now they're thinking we're isolated that, everything is good, we're using this cloud service. So writing your own policy logic, I've seen scary mistakes, and this brings us back to like the 90s. This is path traversal. Welcome back, path traversal. Like, where have you been? So the whole idea here is like, you ask the website, please get me a signed URL for an image. And you said, can you please give me an image for ... And what happens is that one will just try to normalize the path you gave it, and just, here's a signed URL for the bucket. And then you have full read access to every object, and you can also list the files. Another example was basically you post to a S3 URL signature, but it was actually checking a bunch of stuff like, oh, what domain do you have, and like how can you, like you cannot trick us. But I was able to find a bypass. So as you see here, it actually points to S3 Amazon AWS / example beta. But the thing is, that's exactly the same as the root. So the bucket is called example beta, and I just pointed to that. So I could full read access to every object and to every listing. Another example, like I'm not gonna stop. So S3 file, and you tell, please, here's a random key, and here's also an S3 key. And I'm like, oh, okay, S3 key /. What do you think about that? And he would say, oh, that's awesome. I'm gonna create that. So just because you use the random key XX11, I'm gonna put a URL on secure.example.com /files like /XX11, and that one is gonna redirect you to the file called /. So now I have full read access to every object again. This bucket was crazy though, because this was a company that had one bucket for everything. And I have, like, after my research on that bucket, I had a 2 GB file with only the file listing. So it was crazy. And during my research, like, there was a bunch of companies that just exposed all their content for all their users. You could either delete everything, modify anything, or just download anything. And one of these companies, the ones having the largest bucket, they were like, okay, here's $25,000. Like this is basically game over if this would get out there, this content. And remember, this is like 2 GB storage of file listing. Like, imagine how much content it is in that one. Moving over to postMessage. postMessage, if you don't know what postMessage is, it's basically like a very convenient way for iframes on a website, or a website opening another website to talk with each other. It kind of makes sense with the iframe thing. Just open a new tab from another browser, getting them to talk with each other. I don't really agree it's an awesome thing, because you can really exploit that one, and I will tell you why. But the whole idea is that you can send messages between windows and different origins. The whole way to use postMessage secure is that you make sure you know who was sending the message. So you need to verify the sender every time. When you have a scenario where you need to remember to validate, people are gonna forget. Like, that's not secure by default. That's insecure by default. So people are gonna miss this thing, and this is what happened all the time with postMessage. You probably know what Slack is. Slack has a desktop app, but it also has a really good and similar to the desktop web app. So a lot of people are using it in the web browser. This was my attack vector. I wanted to attack someone using the web app. And Slack has a bug bounty, so I was thinking, let's do it. Windows postMessage actually emphasizing safely, which is not really true, but it's more safe than probably, like, I don't know, sending fragments or whatever. Like, it's not really safe at all. I just removed that. The whole way that it works is that you can actually watch in the browser. You can go to elements and event listeners, and you will have a section called message. And you can go inside there and see all the listeners of the current window you're in. The whole way it works, this is an example from a function, is that you said add event listener message, point to this function. This function will then, as soon as a message is sent, will get an event. And this function, as you see, this was Slack's own post message. You can see that the thing that receiver of the message needs to validate is something called origin. And the origin is telling you what domain it's sent from. And looking at this function, we can easily see that it checks if the data property exists and the message type exists. And then it's gonna move further, and then it's gonna make sure that another data field you sent is matching the call window, which is when you're gonna make a call. So you see that, and like there's no origin check at all. So basically, my website can open Slack's website and then send a message, and I could control all the commands in this list. So I started looking at that, and like, this is super exciting. What can I do? I could probably get like something to steal data. The first thing I saw, like I can send notifications. Like that's so boring. Like you can write to that guy and you will get the same attack. So I was like, okay, this sucks. I want something else. I want something more fun. So I saw this functionality, and also in the code, the call function and the call window, and I wondered what that was. So I pressed on it and it opened a new window. And it was opening on, like, if you have blah blah.slack.com, it opened on blah blah slack.com/call. This one also had a post message, because I went through the regular ones and they were like super boring. You could basically, notification was the coolest thing you could do. But looking at this call window, I found that it was using a quite similar code. But the difference that it was checking if the message type was sent to the call window, not from the call window. But when I started looking at this, I saw that there was a bunch of like switch cases depending on the message. And I found one that was like, okay, message to call window MS message. And I looked at this function, message received, and I'm like, okay, that's a lot of things I can simulate. And I started looking at it and I'm like, what? This is a lot of things. So this was just a matter of trying to, what this means is that Slack connects to a socket, and when it connects to a socket, it gets a bunch of messages depending on what's happening in your team. And depending on what's happening in your team, you get different message types. So it has like handlers for all these message types. This means that if you get like someone change the purpose of this channel, that this one catches that and makes something specific for that thing. So in the case of call window, the call window could actually show you like you're in a call right now, you're in a group call, you blah blah blah. The thing was, I started looking at these functions and like I need to find something that looks interesting, and I found one called reconnect. Reconnect was awesome because what it did was it take a parameter and then it would use the reconnect URL. And as I'd said, Slack uses something called WebSocket. And in the WebSocket URL, there's something called a token. And if you know about token is like the precious little combination of your user, password, and 2FA combined. It's perfect because you can actually do whatever the user can. Here's a guy with a horse. So when I saw that, I was like, I need to test, to build my own WebSocket, send a message saying, please reconnect to my socket instead. I made like a super easy ratchet. I actually like on open looked for the token parameter, wrote this code to like, okay, now I'm gonna point to my socket instead, and I'm gonna steal your token. And I started my WebSocket server, and I sent a message saying, please connect to my domain instead with ports which I'm using, and this WebSocket, and please reconnect to that one, and I will get the token. And I was sitting there and like, nope, did not work. And I was like, why doesn't this work? So I found another function called goodbye, and I was thinking, okay, so I probably first need to disconnect, then reconnect, so I need to like fiddle with this. So let's do goodbye and then reconnect. And I tried, nope, did not work. So I thought to myself, let's just stress it. I saw that it was doing stuff, it was just not connecting to my URL. So I thought to myself, let's run a bunch of reconnects, but then at the same time run a bunch of goodbyes simultaneously. And I just like, let's make it crazy and just do all these things at the same time. And suddenly we have a token. Yes, we have a token. The problem was, I wanted to attack more than people that I knew of. So if you know about Slack, you have like a team domain. So if I want to send a link to a user and I want them to click on the link, I want to attack them, that's it. I want to attack them automatically. But I don't know what team they are in, right? So I tried this a lot, and I figured out there is one called my.slack.com, which is redirecting you to the one that you're currently in. And the cool thing was, I wanted to go to the call window. That was the one having the reconnect and the goodbye. But the problem was, as soon as you went to the call window, it would say, you found a glitch. And the reason is, you need to say who you want to call. Ghostbusters. No. I was trying at least. But you need to specify user ID that you want to call. The problem is, I don't know your user IDs. But there's a easy trick of that. And it's the same regular trick in APIs. If you want to look for users, look for me. So you take call/me, which is a brilliant idea trying to call yourself. It would redirect you to thisismylandcall.me, and it will get you the call window, which is magic. So now we can combine this. We can redirect the user or make a link. This link would go to slack.com/call/me. As soon as that is done, that window will get a bunch of messages. It will get like every 2 seconds, it will get a goodbye, and every half second, it will get a reconnect. At the same time, I will start a WebSocket somewhere else and just wait for a token. And we got it, and I was like super happy. I actually sent this report on my birthday. Like, that's how I spend my birthdays. But it was like, happy birthday, me, call me, and like, yeah, that was weird. But I sent them a report, like, this is a funny, weird thing I found, like, I can steal your XOXS, which is like Slack tokens of Slack. And I can redirect it. 5 hours later, this was on a Friday night. Also Friday night on my birthday, I'm sitting at home, like, I sound like a sad person, I'm sorry. But that's the truth, right? We're nerds. And 5 hours later, they say, we pushed out a fix. I looked at the fix, and they had like a verify origin URL. It was checking, and I looked at this, and I'm like, this looks pretty smart. Like, they take the origin from the message, puts it inside a anchor link, and then check if the host name matches the current host name. I'm like, that's pretty smart. Like, why couldn't you just compare two strings? Why would you need to do this advanced thing? But they wanted to, they had probably some reason for it. And I'm like, great job, have an awesome weekend. And after the weekend, they actually paid like $3,000. And I was like, this is impressive. 5 hours patch, awesome patch, super nice to work with. I made a blog post, and it like blew up in the media. Like, oh, and the good thing with this, like, they fixed it in under 5 hours. So they got a bunch of positive press. Like, this could have happened, but imagine, see how awesome Slack is and cool they are. And then Reddit comes. And like, you can bypass that. I'm like, what? I've just like blogged about it, screamed like Slack is awesome, they were doing an awesome thing, and suddenly I just like totally exposed them being vulnerable to a bypass. He's like, yeah, if you have a null origin, the string is just null. So if you have a href on a website with just the word null, that's on the same domain as, it's just a /null. So I tested, and I did the same thing. I did like on a data URI. And when you send it, as I said, you get like href null. The host name is the same as you're on, because it doesn't leave the website. So I get to learn something from a Reddit user. And I actually went back to Slack and like, I'm really sorry. So I'm actually done. Like, the walkthrough is just a bunch of math. But we do automation. We know that crowdsourcing is a cool thing with it. Modern doesn't mean modern. It means widely used. Developer and security awareness is awesome. So for me, being a developer, I can just recommend you to also explore the security field. That's it. Thank you very much. I don't know, how does questions work here? But I don't know. If someone has questions, they could scream them or come afterwards, I think. Thank you.